Okay, so continuing along, so I've got 105.1 milligrams of calcium. I'm going to use this as my first conversion factor. I want to have the milligrams on the bottom because I like to cancel that out. So I got 1,000 milligrams to 1 gram, and this is of calcium. So I'm going to go ahead and cancel out what I can. So I got milligrams of calcium, canceling out milligrams of calcium. And now I'm going to use this other thing to go from grams to moles. Now you could actually go directly from grams to atoms, but generally chemists tend to go from grams to mole and then from moles to atoms. So I'm going to go ahead and do that. So I'm going to have 40.08 grams of calcium to 1 mole of calcium. And you can see that I've got grams of calcium on the bottom. It's going to cancel out. I got grams of calcium on the top. It's going to cancel out. So now I'm up to moles of calcium, but I'm trying to get to atoms of calcium, so I'm not done yet. I have to do one more conversion factor. So I'm going to do in 1 mole of calcium, I have 6.022 times 10 to the 23rd. Ooh, lack of planning on my part. Atoms of calcium. Okay, so let me cancel out what I have. That's the same. I've got moles of calcium, canceling moles of calcium. So what I have left after I go through all of that is I've got atoms of calcium. This is the only thing that I still have left at the end of the calculation because everything else has canceled out. So I stick it into your little calculator, and keep in mind when you're putting numbers into your calculator for something like this, all you have to do is stick into your calculator sequentially 105.1 milligram, punch the divide button, punch in the 1,000, punch the divide button, push in the 40.08, and then punch your little multiply sign and put in this as an exponential number, and I hope you all know how to do exponential numbers in your calculator. And then we get as our final answer 1.579 times 10 to the 21st atoms of calcium. Now, let's look at the number of significant figures. So I got 1, 2, 3, 4 significant figures. I got 1, 2, 3, 4 significant figures here. Everything else was either had the correct number of significant figures or was a definition. So, for instance, this 1 gram per 1,000 milligram is a definition, so it has an infinite number of significant figures. So this is the correct number of significant figures because all of this was multiplication and division. So you just go by the lowest number of significant figures, which was 4. Okay, so that's your answer to that question. Alright, let me ask another question. So here's another example of the kind of question that you could be asked. So what kind of question are you likely to be asked on the next exam or quiz? This kind of question right here, this is the kind of question I like giving as a long answer question. Those little questions that I asked earlier where I had little fill-in-the-blank kind of things, those are the fill-in-the-blank kind of questions that you're likely to get. So next quiz or exam, you're likely to get something like this. Now, if you get something like this, if you set it up correctly, you'll get the majority of the points. So if you set it up all correctly, everything is in the correct place, and then you stick it into your calculator wrong, and you give me 407.9 times 10 to the first atoms or something like that, let's say, then you're not going to lose the majority of the points. You'll lose maybe half a point for math because you set everything else up correctly. I mean, I'd like you to be able to use your calculator, but I think with a little bit of practice you should get to that. So you're only not going to lose all of your points for doing something like that. So 10-point question, half a point off if you manage to stick it into your calculator wrong and come up with the final wrong answer. If you set this up incorrectly, you're going to lose a lot of points. But look at how easy this is. You hardly have to know what you're doing because all you have to do is you're just doing the same old dimensional analysis that you were doing in Chapter 1. So this is the same as when you're going from miles per hour to millimeters per second. Because you're just multiplying. This is an equivalent number. The top is equivalent to the bottom. This is an equivalent number. The top is equivalent to the bottom. And you just have to keep straight everything that cancels out, and you have to make sure that the unit of the final thing that you end up with that doesn't cancel out is the unit that you're trying to get to. Right? So it's actually a very simple problem if you just approach it that way, instead of thinking, oh my God, what the heck is she asking? I don't know. And, it must be something very complicated. Don't think that. Just, go stepwise, and it'll just sort of falls into place. Okay, so here's another question that I could ask, and this would be, how many moles are in 2.24 grams of lithium? Okay, so we look at the periodic table and we look up lithium, and you notice that the lithium, one atom of lithium, is 6.941. This is the atomic mass unit for one atom of lithium. So one atom of lithium weighs 6.941 atomic mass units. Okay, so we have the number of grams, so we're trying to go from grams of lithium to number of moles. So you got 2.24 grams of lithium, and we're trying to get to how many moles? This is actually a very simple problem, because all we're going to do is we're going to write down 2.24 grams of lithium, and we're going to use this as a conversion factor. So we're going to say 6.941 atomic mass unit is equal to 1 mole of lithium. Sorry, not atomic mass unit. Grams of lithium is equal to 1 mole of lithium. And then you notice that everything cancels out. So grams of lithium cancels grams of lithium. I get moles of lithium. You stick it into your little calculator and you get out 0.32272. This is what your calculator puts out. We look at the number of significant figures. I got 3 significant figures here. I should only have 3 significant figures here. I round up, so then I get 0.323 moles of lithium. Okay, so there is that question. So then the other question I could possibly be asked on this kind of material could be, I could ask you the following. So the question is, how much does 4.23 times 10 to the 24th atoms of iron weigh? So there's my question. Okay, so I look at the periodic table and I can see that iron has a mass of atomic mass of 55.85. So then I know 1 mole of iron is equal to 55.85 grams of iron. And then I also know that 1 mole of iron has 6.022 times 10 to the 23rd atoms of iron. So there's my little conversion factor from all the stuff that I figured out from this chapter. Okay, so I'm going to go ahead and write down what I know, and then I'm going to get to where I need to go. So I'm starting out with 4.23 times 10 to the 24th atoms of iron, and then I'm trying to get to grams of iron. Alright, so I've got a couple of conversion factors there that I can use. And so I'm going to sequentially put in the conversion factors. So I got 4.23 times 10 to the 24th atoms of iron times, and then I can say that in 1 mole of iron, I have 6.022 times 10 to the 23rd atoms of iron in 1 mole of iron. And I do understand that when you look at this, you might think to yourself, well, why don't I just put, instead of going from atoms to moles, why can't I just put 6.022 times 10 to the 23rd and then put 55.85 grams on top? And you'd be fine. If you did that, you'd get full credit. Generally, chemists tend to go from atoms to moles and then from moles to grams. And from grams to moles and then from moles to atoms. But if you want to do it that way, that's fine. But usually the reason why chemists tend to do it like this is because if you start skipping steps, so in this conversion factor, if you have 6.022 times 10 to the 23rd atoms, and then you get grams of 55.85 grams of iron, and then leave out that little step where you convert to moles, you tend to make mistakes. So to eliminate mistakes, it's usually best to go ahead and go to moles before you go to the grams. Alright, so I've got in 1 mole of iron, I have 55.85 grams of iron. So let's look at this and make sure that we didn't make any mistakes. So you got atoms of iron canceling atoms of iron. And then I look over here and I notice I've got moles of iron canceling moles of iron. The only thing I have left at the end of the problem is grams of iron. And what was I trying to get to? I was trying to get to grams of iron. So I'm good to go. All you have to do is stick all the numbers into your calculator, crunch the numbers through, and I get out 392.43 grams of iron. And once again, I had 3 significant figures here, 3 sig fig. And my answer should also be 3 significant figures because that's the limiting number of significant figures, and I'm doing all multiplication and division here. So the final answer should actually be 392 grams of iron. Now, once again, if you set this all up, stick it into your calculator, and you give me this as your answer, are you going to lose on a 10-point long answer problem, word problem, are you going to lose 10 points? Well, no, you're not going to lose 10 points. You're going to lose maybe half a point for significant figures. This is the absolute correct final answer, but if you give me this, you'll get, out of a 10-point question, you'll get 9.5 points. Okay, so that is all I'm covering out of Chapter 2, and I'll see you when I get back from the ACS meeting.